In this video I'm going to cover the SUVAT equations, when to use them, and two examples. So SUVAT is an acronym where S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time. So there are four equations that you need to know, and they are V equals U plus AT, that should be capital A. As long as you know its acceleration, doesn't matter. S equals ut plus half at squared. V squared equals u squared plus 2as, and S equals u plus v over 2 times t. So that's just the average of the two velocities. If we go for an example where a car initially at rest with a constant acceleration reaches a speed of 50 meters a second after half a mile, what is the acceleration? So the first thing you want to do is draw a picture. So you've got the road, fantastic drawing of a car there. You've got distance of, I haven't specified a distance. Yes, I have, sorry. Yeah, half a mile. So that's the distance. You need to define which way is positive. So the car in this diagram is going to the right. So say right is positive. And the next thing we need to do is write down what variables we do have. So S, we have S, it's half a mile, which is about 800 meters. U is the initial speed, so it says initially at rest, so that's going to be 0 meters a second. Final velocity V is given here, 50 meters a second. Acceleration A is what we're trying to find, so leave that variable as A. And T, we're not given T, so it's irrelevant in this. So if we look at the equations we've got the one that we want to use, the one that hasn't got a t in it. So it's not this one, not this one, not this one. So it must be this one. So v squared equals u squared plus 2as. You know that the initial speed is 0, so this term is going to go to 0. So you have v squared equals 2as. A is what we're trying to find, so if you rearrange this for A, you have A equals v squared over 2s, and then put in the numbers. V is 50 meters a second squared over 2 times s, which is 800 meters, and you find that the answer is approximately 1.56 meters per second squared. If you want to do an example that is in 2 dimensions, this is an example to use. So a ball is thrown horizontally at a speed of 10 meters a second from a cliff that's 500 meters tall. How far would the ball be from the bottom of the cliff when it hits the floor? So same as last time, first thing you need to do is draw a diagram. So here's a cliff, you know the ball is thrown horizontally at 10 meters a second, and you know that the cliff is 500 meters tall. And you need to define which direction is positive and negative again. So if you take the horizontal to the right to be positive and downwards to be positive. So the way to solve this is to consider the vertical components first. So you know that S is going to be 500 meters. U is going to be 0 because it's thrown with the horizontal component, there's no vertical. V is not mentioned, so just leave that out. Acceleration was being thrown off a cliff, so it's going to be gravity. So it's going to be approximately 9.81 meters per second squared. And t is what we're going to try and find. So to solve this, you want to use s equals ut plus half at squared. You know that u is 0, so this term's going to disappear. So just left with s equals half at squared. Rearrange this for t, and you get t equals 2s over a all square rooted. Putting in the numbers, you have 2 times 500 meters divided by 9.81 meters per second squared, square rooted, and that gives you 10.096 seconds, which is approximately 10 seconds. And now you need to use the horizontal bits, so you know that s is what you're trying to find, so if you leave that as s, u is 10 meters a second, v is not mentioned again, a is 0, so assume there's no air resistance, and t we just found up here is about 10 seconds. So the equation we want to use here is the same as this one before. So s equals ut plus half at squared. You know that a is 0, so this term's going to go away. So just left with s equals ut. Put in the numbers, and you have 10 meters a second times the time of 10 seconds is 100 meters. So the ball is going to fall a bit like this, and this distance here is 100 meters.